Good morning, students. In our last lecture, we look at two internal control frameworks that has been promulgated, the COSO framework and the COBIT framework. In today's lecture, we want to look at internal controls in more detail. So the study covers these 5 objectives. First, we need to evaluate controls relating to the stages of data processing and the COSO and the COBIT framework. Now you realize that data processing involves about 4 key stages. That is data entry. So the controls relating to the entry of data. And you know that most of these fraudulent acts actually occur at the data entry stage. If the perpetrator is able to manipulate the data that will be entering, then they will be successful in their acts. So look at controls at the data entry stage. We also look at controls at the processing stage. Once data has been entered, it must be processed. And one of the 2 key risks that are associated with processing, they are the program fraud that are related to programs, and then operations fraud. We also look at the aims of computerized accounting. Computerized accounting is all about using computer to perform accounting transactions. You know that we have been dealing with the manual processes, that is passing books of original entry from first principles of accounting. That is using the days book, the sales day book, the purchases day book, the trial balance that will extract, and then we prepare financial reports. So this report is now being generated with the aid of computer. Okay, so in the computer, we have 4 key files that performs all these journal functions. We know we have the transaction file, the archives file, and then the master file, right? And the other one, okay, which I've forgotten. Then we need to explain and provide examples of general controls. Now you realize that computer controls comprises 2 key types, and this has been identified by the COSO framework. So the COSO framework identifies 2 general types of computer controls. You also note that computer controls, they are part of general controls. Okay, so we have what we call IT controls, which is a subset of internal controls. And these controls are grouped into what we call general controls and then application controls. Now, general controls actually involves control over the entire system, such as physical entry, password. How do you allow people to enter the system in terms of the physical assets and so on. Then we also have application controls, which are specific. They are application specific to the various transactions, such as sales processing or sales order processing. There must be control relating to purchasing. There must be controls relating to inventory and so on. Okay, so look at them. So critique the execution of control activities, and then explain and provide examples of application controls. So as I've just explained, we have 2 types of IT controls. So we also look at examples of application controls, and then evaluate the operation and components of a disaster recovery plan. Okay, so like we studied in our last lecture, that IT governance involves 3 key elements, right? the IT infrastructure, the physical computer governance, and then disaster recovery plan. See, so we know that we don't expect disaster to occur, but we have some kind of disasters that we will find it very difficult. We don't have control over them. So how do you plan for such occurrences of disasters? Okay. So in our first objective, we have to evaluate controls relating to the stages of data processing. But before we do that, we should note that information technology drives the financial reporting process of modern organizations. You know that this control is all geared towards quality in financial reporting, right? We need to report and make sure that our financial reports are free from material error. You see, the information in the financial report is complete and subject to free material error. Okay, so we also got to know that control cannot be complete. I mean, we cannot have 100% internal control, but we can control to a reasonable amount. So to provide a reasonable amount of control. So automated systems, as we know, they initiate, they authorize, and then they process or they record, and then they report. You see, so transactions actually, before the financial report will come out, it goes through various stages. Somebody must initiate the transaction process. Somebody must authorize the initiation. So if there's a sales order, there must be authorization. If purchases are going to be made, there must be authorization. And that is one of the key controls in all stages of the data processing. So even inputting of data, there must be authorization. So who is inputting the sales order data? Who is inputting the purchases data? You see, so authorization. And then we record before we report. So it's about automated system, which we know that is the key objective of computerized accounting. So it's to automate the system or the financial reporting process. So that is to record, and all these can be performed by just an application or a single application of a button, right, in the computerized system. But when we come to the manual system, you see that we have various set of books that will cater for all this. But a single application in the computerized system will process all this. So there should be somebody that must authorize. And authorization, evidence of authorization is normally, it comes with signatories, right? Okay, so the financial transaction, right, what I was even saying, okay, so initiate, authorize, record, and report the effects of financial transaction. All right. So as such, these automated systems, they are considered as inextricable elements of the financial reporting, of the financial reporting process. They are not isolated from the financial reporting process. So that the Sarbanes-Oxley Act, you see, have considered that they must be what? Controlled. So the COSO identifies two broad groups of internal information system controls. So we have the application controls, and then we have the general controls. Okay, so we'll look at this as we progress. So now let's look at the stages. So I indicated earlier on that there are about 4 key stages. That is data collection and data entry, and then data processing. So when the data has been processed, it must be stored in the database management system, and then we generate information. But let's look at the COSO framework as we look at it the last time. The COSO framework now is a general framework for which most organizations have adopted. Okay, so it assesses internal controls over financial reporting. As I indicated, financial reporting must be accurate. It must provide a complete information. That is, the information contained in the financial reports must be complete, and so on. And it is used by most US organizations. Obviously, this COSO framework originated in the US by the SEC, that is the Securities and Exchange Commission. We also have Securities and Exchange Commission in our country here, which regulates the listing requirements on the Ghana Stock Exchange. So used by most US organizations as well as organizations around the world under the US Sarbanes-Oxley Act, right? We know that the Sarbanes-Oxley Act was promulgated in 2002 to regulate the activities of public organizations because of what happened around the world. Most of these giant companies were collapsed or were they went through financial scandals and so on. So that was the basic aim of the act. And then the COBIT is actually designed for information technology controls. So this was released by the the AIS, right, in 2012. And is a framework for the governance, internal control, and management of IT, enterprises IT, as I've already indicated. So the governance, the internal control, and then the management of enterprise IT. So it covers general IT controls, but only the development aspect of application controls. So what we mean is that this framework actually covers the general control aspect, but it has only developed the aspects of application controls. Okay, so there are 6 application controls that we can identify in the COBIT framework. So source data preparation, as I indicated, the first stage of the data processing activity is the data that will enter the system. So if somebody is able to manipulate the data, he can manipulate it by actually altering some data figures or deleting some transactions or creating a transaction into the data. All these are ways of manipulating the data. Then the person or the perpetrator will be succeeded, because that is a stage that all the data that we need for the information are passed. So source data preparation and authorization, you see, as I've indicated, authorization is very important in all transactions. So who is entering the data? That person must be authorized, right? I remember that I needed some kind of computing assistance. Was it my, I think it was my, I needed an ID, yes. You know, in the university, even if you have your password, the system will ask you to enter your PIN, good. So if you are going to MIS, if you enter your password, you have to also enter your PIN. So when I went, I met a lady and she told me, oh, she doesn't have the capacity to do it. So unless the people themselves, they are in. So here, authorization, if she has been authorized to generate the PIN, he will have been given access. So she wasn't given access because she has no authority. So source data collection and entry. Okay, so these are the key areas that we need to provide controls. So what are your controls in terms of data collection, in terms of data entry. Who is collecting the data? What rules, policies, regulations that cover the collection of data according to your company, and how do we enter data and so on. Then accuracy, completeness, and authenticity checks. You see, all these must be performed. We check for accuracy. One of the approaches is what we call check digits, right? Or it's just about code. So the code will check whether the data that you are inputting is accurate, whether the data is complete, you see, and whether it is authentic. And then the processing integrity and validity. So we also have controls relating to data processing. And here, the two key risks that we can identify in the processing stage, there is what we call the program fraud and then the operating fraud. We'll look at them as we progress. And then the output. So you see, this COBIT actually focuses on the processing of your information. The information that enters, the information that is processed, right? That is data that enters the system, the data that is processed, and then the output. So output review. How do you check that the data that was entered was the information that has been produced? Of course, we know that some data must be converted, or data actually is transposed or transmitted. And sometimes you might see some changes. But we need to reconcile whether there are no errors, right? For example, you need data for, let's say you are inputting data for accounts receivable about debtors. You see, then you mistakenly, or even when you have added some digits to the figure, the figure, let's say, is supposed to be 100, but then it has come out as 1,000, you see. Then transaction authentication and integrity. Okay, so all these are these 6 stages is what the application control and the COBIT, that is control objective for information and related technology. That is what it specifies. So we know that, as I indicated in our previous lecture, internal auditing, internal control, they are the basis for corporate governance. So the auditor will identify and test input controls, you see. As an auditor, we'll look at auditing in our next lecture. So he has to test and has to express his or her opinion on the input controls, whether they are what, they are adequate, whether there are no material weaknesses in these input controls. He has to also express opinion on processing controls. So the controls that has been put in place in terms of processing of data, you see, and then there should be also controls in the output of information. Are you okay? And moreover, interface control. So what we are saying here is that as an auditor, you should note that we don't have what we call a one-size-fits-all. You see, for example, you have controls at the input stage, and that is it. You assume that those controls can cater for all the other controls and in the other stages of operation. No, the input controls are different from the processing controls, and the processing controls are also different from the output controls. So controls are not a one-size-fits-all approach, right? So important to understand the business process. You see, so we said that the business process actually comprises what the organization has been mandated to do. If you are picking a manufacturing company, you have controls at the the 3 stages or the three categories of activities that characterize every manufacturing company. The input logistic, you have controls at the input logistics. The input logistics is where we have, we procure for raw materials, we procure for other resources that are to be transmitted or transformed into finished products. So at the input logistics stage, you see, there must be control about purchases, who authorize for purchases of raw materials, and so on. And then the processing of information, so that is the manufacturing operations. Again, there must be controls. The controls in the manufacturing operations will be different from the controls in the input logistics stage. You see, then we also have the output logistics, you see, which we sell finished products to our customers. The controls at these stages will also be what? Different. Okay, so when you look at each stage in the AIS, right? In the AIS model, you remember we did the generalized model for AIS. So each stage in the AIS model, we have the data collection stage, we have the data processing stage, we have the database management stage. That is where we store data and retrieve data, you see. And then we have the information generation stage. So each of these stages is a potential risk or area of risk that we can identify. There are potential risks that can be identified in each of these stages for certain types of computer or fraud. Okay, for which we need to put measures or control activities to minimize this kind of fraud. So the data collection stage, here most common access points, that is the most common access point for perpetration of computer fraud. That is the most common access point for the perpetration of computer fraud. So first, operational stage in the information system, right? And then control objective is to ensure that event data, so any data that is being entered or event data that are entering the system are valid. So for example, if there has been a transaction about sale or about purchases, then there shouldn't be any alteration of the data, or there shouldn't be any new creation of purchases which does not exist. You see, so those are some of the frauds. So valid, complete, and free from material error. Then we also have erroneous or fraudulent transactions. So here at the data stage, we can identify all these type of transactions. So fraudulent or erroneous transactions, which pass through data collection undetected. Then the organization will risk that the system will process the transaction and that it will input or impact this on the financial statements. Okay, but there are two factors, what we call masquerading. Masquerading is where a proprietor who has gained access to the system, right? And this access is gained from getting access to a password, an authorized access to a password. So he has gained access from the remote site to the system, and he pretends to be an authorized user. So that one, we call it masquerading. But when you talk about PG blocking, is a technique in which the perpetrator at a remote site taps into the telecommunication lines, you see, and latches onto an authorized user who is what logging into the system. But when you talk about hacking, the hacking comprises both masquerading and then PG backing. So as for hacking, they are, you see, most of the time hackers, their intention is not to steal, but they want to challenge um, the breaking into the system, you see. Okay, so these are all kinds of computer fraud that can associated with the data entry. Okay, so describe the aims of a computerized accounting. So that is our objective 2. But before we come to objective 2, I think I've just spoken about the data entry controls. So the risk that can be identified at the data entry stage. And then the data processing stage. So when you come to the data processing fraud or risk, then we can classify them into 2 or group them into 2. We have program fraud and then operations fraud. I think I've already indicated this. Now, program fraud includes creating illegal programs that can access data files to alter. So you are creating an illegal programs. That's why we say it's what? It's a program fraud. So the system analyst, this is normally associated with those who have actually read computer science. So they can create programs that can access data files. And in order to alter or to delete, you see, or to insert values into the accounting system. You see, so this is very, very dicey. And then they can also destroy or corrupt a program, the logic that the computer uses. So they can destroy or corrupt a program's logic using the computer virus. They can do that. Or they can also alter program logic to cause the application to process data incorrectly. You see, to cause the application to process data incorrectly. So when we come to processing fraud, then one of the key areas is the program fraud. But when you talk about operational fraud, then it's all about whether you are misusing or stealing the firm's computer records. You are stealing the firm's or computer records, right? And then if you are using the computer to conduct personal business, then that one we classify it as what? Operational fraud. So using the computer for your own private business is an operational fraud. People don't see this as fraud, but it's a fraud. Okay. So example, let me give you an example. That is, the programmer may use the firm's computer time. You are using a computer time to write software that are sold commercially. You see, and this can be done by the program. As for the accountant, his knowledge is not up to that. The CPA, for example, that is a certified public accountant, in the controller's office may also use the company's or the computer to prepare tax returns and financial statements for her private clients. Yes, normally the CPA has private clients that he deals with, and he can come to the office and use the company's computer system to do that. You see, so data processing task is actually includes the mathematics. We have mathematical algorithms, such as when you talk about linear programming, and there are several linear programming models. We have multi-objective functions and so on. But when we talk about the data processing, then there are these models. Example is the linear programming models. Or we also have what we call in fact, the linear programming models, one of the applications is to schedule production. See, because linear programming, as you did it in quantitative methods, you know that it is used for the allocation of scarce resources. So if your resources are scarce and you need to allocate it among competing outputs or activities, then you can do this efficiently by using what linear programming. Then we also have statistical techniques. We have several statistical approaches, but we can use them to forecast sales, such as forecasting of sales. We can use linear regression analysis to forecast sales. So that's a statistical technique. And then we have what we call posting and summarizing. We have posting, and then we have summarizing procedures. You post and then you summarize, and it's used for accounting applications. So that is actually what happens in the data processing stage. You see, so these can be compromised. So the data processing fraud, they fall into two classes. So I've already explained that. Okay, so let's go to the information generation before I come to the other ones. So information generation. But we know that when we have processed the data must be stored. And that is, it must be stored in the computer's database. So we have what we call database management. And again, there are some risks that are associated with database management. And we can have where somebody can alter, or somebody can delete, somebody can corrupt, somebody can destroy, or somebody can steal the organization's data. So you see, the data are stored in the organization's database, and all these that I've mentioned, they can happen to the data. So the physical repository of the organization's activities, the database, you see, so those need to be controlled. What control measures will prevent or will minimize any of these acts? So will prevent somebody from altering the data, deleting the data. For example, in this university, you realize that your resource, they are the data that the organization will keep to process it, to enable you to graduate. Now, assuming your resource is missing, the data about your resource cannot be found. How can you graduate? You see, so this is very important. Okay. Then from the processing stage, we then generate information to be given to users. We know we have two key users, internal users and then external users. So the process of compiling, what is information generation? It's about we compiling, arranging, formatting, and presenting information to users, right? So we compile, and then we arrange, we format, and then we present. Okay. So computer fraud at the information stage. We can also have some fraud at the information stage, such as stealing. Somebody can just steal the information. You see, if this information is made available to your competitor, you see, then that will cost you a lot, because some information are confidential. They must not come out. So if somebody gets access to the information and steal it, and then send it to your competitor, or misdirect or misuse computer output. And the output I'm talking about is the information. So the information is serving a particular purpose, but then that has been misdirected or misused. And we have all this that we need to control. Okay. So the auditor must perform tests covering all these processing controls. So test at the input stage and then express an opinion. Test at the processing stage and express at what? An opinion. So we have the input controls. You need to test to see whether there are no material weaknesses in the input control system. You express your opinion. You test for the processing controls. You also what? Express your opinion. Test for the output controls and then the interface controls, and you express your opinion. Okay, so when we come to information system audit, I think we'll go through this again. Then we have controls that are not okay. I think I've already explained that. So let's continue. So now, learning objective 2 says that we need to describe the aims of computerized accounting information system. And as I indicated in my earlier statement, the main objective for computerized accounting system is that we need to process accounting data with the aid of computer. So if you want to go into automation, that is, want to automate accounting processes, right? So it's all about automation. And you see that if we want to automate, then we need to get the software that will be needed. We need to get the hardware, right? So let's look at the system. Let's look at the aims. The system should aim to ensure transactions are properly authorized. So this one, we are assuming that you have already acquired your system. You've already acquired your system, and then you are operating the system. So remember that when we say computerized accounting, it is a variant of accounting information system. Now, accounting information system can be manual. You see, so we say that accounting information system is actually to just ensure that the rules, the policies, the procedures about data collection, about data processing, about data information generation, about giving out information to users. You see, all these, the company has some procedures, the company has some rules, the company has some policies that govern all these activities. But this can be done in the manual form, and it can also be done in the computerized form. So here we ensure that transactions are properly what? Authorized. For example, if you are collecting data, it is not everybody who must collect data. You see, there must be policies and procedures governing the collection of data. There must be policies and procedures governing the processing of data, the recording, and the process in their entirely and in a timely manner. So that is what computerized accounting actually aims to achieve. And computerized accounting basically aims to automate the system, because computerized accounting, as we all know, has several advantages compared to the manual system. Okay, so appropriate authority given. All the key areas I've mentioned is what we are taking them step by step. Appropriate authority must be given prior to the execution of transactions or the modification of software. We have various software that we use, and currently we see that the software from the SAP, we have several models of SAP. So it is not that you go in for all models, no. So if you want to acquire or procure a software, then there should be an authorization that must be given to the software acquisition. Or if you want to modify your software, maybe you want to upgrade it. Yeah, that is, you need to be given authority. Then computerized information system, user privileges, access rights, and user restrictions. So users, you must be provided with access. You must be restricted into using the information system. And the manual paper-based system, you see, I mentioned that the AIS actually is made up of both computerized and manual. So approval of invoices over a certain amount. We know that in some organizations, if some amount, we have some limits for which you have to approve, and some limits must go beyond you to some cortex for approval. And then valid transactions are when the transaction actually occurs. Yes, if the transaction has not taken place, how do you get the transaction? But people can create non-existent transactions in order to get money, fraudulent funds into their pockets. So it's when actually the transaction occurs and the parties involved actually exist. You see, so we must see the transaction that has occurred before we can record. And when we talk about proper recording, then this is concerned with the accuracy. So ensuring all data is recorded in the correct format and of the right type. You see, the data accurately records the reality of the underlying transaction event or events. Input accuracy, and this takes us back to the stages in the transaction processing or data processing. So input accuracy, ensuring all data entered is correct at the source. So we don't enter any irrelevant data. If data is not gathered and recorded correctly, the financial statement will not be accurate. Yes. So as for the system, whatever data you are inputting, it will process it. You see, so if the data is wrong, if the data you are inputting is incorrect, it will process the incorrect data and will generate incorrect information. And because of that, decision makers are going to use information that is not reliable. And that is why the auditor must perform tests at all the various stages, because the auditor is providing an assurance, you see, to use the user that the information you are relying on is accurate and it can influence your decision in a positive manner. Okay. Now, input completeness. All transaction events and required data are what? Captured. So if some data is not captured, then you need to check. And we have some controls that must check all this. Then operates at two levels. We have individual level, that is all details for an individual transaction is captured or they are captured. And then the business process model, all activities within the process are recorded. So financial statement perspective, we have completeness requires that all transactions and accounts that should have been recorded have actually been recorded. Okay. So all this is what we are calling completeness. So if significant data have not been entered or recorded, then the transactions or the system will not be complete. You see, so all transaction events and required data must be what? Captured. So if you have left any of the data uncaptured, then we have incompleteness. And this incompleteness must or completeness operates at two levels. So we have the individual level and then the business process level. Then timeliness. Data is captured. Normally when data is captured, it has to be processed. and it has to be stored in the database management system, and then the information will be made available. So we are saying that the information must be timely. If, for example, you need information to predict some transactions, then that information must be available at that time. So transaction processing does not need to occur immediately, because we have what we call the batch processing, and then we have the real-time process. I think we have mentioned this over and over and over. So for real-time, they are processed as a transaction occurs, but for batch, we need to group together a certain number of transactions before we process all of them. So batch processing, and then we have the real-time processing. Okay, so online data is the same as the real-time, right? Online data gathering and batch processing transactions are immediately stored online. You see, but related to the batch, they are not immediately stored. So they are not updated until a decided interval. You see. Okay. So those are the aims of computerized accounting. Now let's go to general controls. Okay, so we're saying that general controls are the controls that covers the entire system. You see, so we're talking about physical controls, having access to the organization's physical assets. The organization's physical assets. For example, we can have computer fraud in various forms. Now, some people consider copying commercial computer software to be neither unethical nor illegal. You see, but those who sell computer software, vendors, you see, they consider such act as what? Criminal. So we have several activities or acts that we consider as computer fraud. For example, if you have stolen, the theft, or you are misusing, or you misappropriate assets by altering what we call computer readable records, the records that a computer is able to read, and files. This is amounting to fraud. Or if you have stolen, that is the theft, misuse, or misappropriation of assets by the use of computer readable information. So theft or illegal use of computer readable information. Or you have stolen, misused, or misappropriate assets by altering the logic of computer software, And there are a lot of them that we consider as what computer fraud. So here, when you talk about general controls, then we are looking at controls relating to physical assets, physical controls. So you can see that we have several control measures. Maybe the whole system or the whole place will be locked up. And if only you have access, you'll be allowed to enter. Or we have what we call, we have some card that we use to open. So here, controls. You remember we spoke about segregation of duties. So duties that are mostly incompatible must be segregated, you see. And those are some of the controls in the general control framework. So you segregate the processing of transaction from somebody who authorized the transaction. You see, user access. So system development procedures, user awareness of risk, and then data storage procedures. I think we'll look at each of these on its own. Okay, so when you talk about physical controls, you see locked computing premises. So maybe your system is said that you can only do that by locking up the premises. Okay, so if somebody wants to enter and the person has access to the system, then the person can be what? Allowed. Or you have what you call swipe cast access. These days, here in this our environment here, we are not far developed, but in advanced countries, keys are things of the past. We use card, even in our homes. We swipe the card and it will open the place for us. Or we have what we call biometric. Now, every organization is trying to adopt a biometric access control. Even the church. In the church, we have biometric registration. So if the system, you remember, if you go to BAM library, there's a research commons, for example, you only enter if you have registered biometrically and the system can identify you. You see, and then Christie, Orist security. We have securities and then security cameras to record access to the premises. So some have just installed cameras around. So they don't need anybody there. But if you come, it will record everything. Who is entering the place and so on. Then segregation of duties is about separating employee duties and their responsibilities in a way. Because if somebody authorizes for a transaction and that same person will process the transaction, then the person will be, having the opportunity to commit a fraud. So you separate employee duties and responsibilities in a way that ensures that an individual employee cannot carry out a fraud without being detected. You see, so you need to segregate duties, then should exist between the users of IT. So here, you see, in our accounting system, we have segregation of duties in the, let's say, the one who pass books of original entry. So authorization is given for the sales order. Authorization is given for the sales processing. Authorization is given for the picking up of the goods. Authorization is given to the dispatching of the goods to the customer and so on. That is, we have some manual processing activities that we put in control measures. In the computer environment, then we have the people who are in the IT section that must be controlled. For example, the maintenance of the IT system. Who is the maintenance of the IT system? The maintenance of IT system has vast knowledge, you see, about IT processes. System designers, you see, they also have vast knowledge. And then those who test the system and others. So the control activities must be focused on these people if you are talking about IT controls, right? Just as we have them in other jurisdictions. So if user is involved in the design process, they can work around controls, you see. All right. Then we have the user access. Logical access, that is where we have your password. So logical access of users to the system within the organization. That is what we mean by user access. The example here is the password, as I've already mentioned, and unique identification code. For example, if you want to go into your MIS, you type your password, and then you must also type your PIN. So that is a code that is identifying you, apart from having entered your password. And password must also be, made up of some characteristics. For example, the format of the password will say that it is made up of both numerical data, both symbols, and so on and so forth. You see, the lives of the password. we have been, sometimes the system will ask you to change your password after a certain period of time, right? So life of the password. So when you have created a password, it does not mean that the password will exist forever. You might change it. Uniqueness of the password. And when a login is unsuccessful, security of written down password. So these are all what we call user access as another control measures. Then when we talk about general controls, we have system development procedures, those who develop the system. And maintenance and development are different information systems, you see. So requires policies, requires procedures and restrictions to the development of a system. Or you have what we call privileges of the user, such as system administrator. The system administrator, we got to know in our last lecture that he has several functions that he performs. So his function must also be what? Separated from others. Preventive control, assurance that untested or incomplete software that has not been appropriately reviewed or license will not be placed on the system. Okay. We have preventive control, we have detective control, and then we have, there are three types of controls, right? Preventive control, detective control, and then corrective control. So for a particular software not to be allowed into the system, it comes under preventive control. We do not just allow the software into the system before we try to correct it. No. So these are some of them. And then users must be aware of risk, information system risk. What are some of the risks in the information system? So it's about fraud, people who can fraudulently operate. Example, briefing sessions about password policies and computer monitoring. You see, you need to brief your users, security threats and issues, organizational security policies, and so on. So one of the controls is that you should make your users aware of risk in the system. So what are the policies for detection of fraud? Data storage. You see, data storage is also privileges and encryption of stored data. We all know what an encryption is. So information about customers, staff, and intellectual property is stored on servers. This is about the database management system. So the database actually stores the organization's data. That's the physical repository of the organization's data. So if released, it could have negative financial and non-financial consequences. And you know that the storage contains information about the whole organization in terms of customers. So in this university, we have storage, which stores information about all students' reports. You see, so, and this student report is the key. That is all what the university is relying on to award certificates. So staff and intellectual property stored on servers. Okay, need to manage data storage links logically or in the cloud. Fine, we can store data logical, we can even store in the cloud, but each of them has its own advantages and disadvantages. Okay, so if you want data access, you need to have to log in, and then restrictions as well. So what are the major risks associated with cloud storage? As I've already mentioned, inability to audit and then monitor at far level, yes, because it's in the cloud. And for cloud, wherever you are in the world, you can have access. So you have inability to access the internet to access data as well. That is also one of the limitations. And then unresolved security issues include data security, network security, data integrity, web application security, and so on. So all these securities have not been resolved. and they come as limitations to data storage in the cloud. So risk in the cloud. Then control, schedule backup, batch or real time. Yes, you know what they stand for, right? So, okay. Then security policies. We need some kind of policies that will prevent or protect electronic resources. So document an organization's approach to security. We need to put in a document form all the approaches that the organization will adopt to security. It must be documented, usually by following a framework and or a standard. Yes, so if you have adopted the COSO framework or the COBIT framework, you see, then that is where you're going to document your approach to security based on the COBIT framework or the COSO framework. Should be understood and used by all users. Yes. So everybody in the organization must understand. If the organization is adopting, let's say, the COBIT framework, then everybody must understand the COBIT framework. And everybody must use that framework in terms of security policies. Okay. So we can see the controls that are normally characterizing the entire organization as well, general controls. But then we also have what? Application controls. And they are normally application specific. So application control, we may have sales order controls. It's an application control specifically. Or we have inventory management controls. Okay, so our fourth objective is that we need to explain and provide examples of application controls. And as I've mentioned, but we group them into three main classes: input controls, processing controls, and then output controls. So it's just like the data processing activities. So we have input controls. What are input controls? Just to ensure that all the data that are being inputted are are free of material errors, are complete, valid, and so on. So built around the operation of a particular process. So it is built around the operation of a particular process, as I've already mentioned. Relate to the key system stages of input, processing, and output. So when you say input, then we have all these data entry routines. We have automated form completion, transaction authorization, batch level, because you can see that all these are what? Specific activities that we can have. If you are sequencing, you are checking, you have sequence checks, turnaround documents, input validity, and so on. All right, so the aim is to ensure that data within the system is what? Correctly and accurately processed. How do we do input control? Let me go back to the input control. We have examples of input control. For example, when we say you are checking the digits, you check digits. But we should note that the application control ensure that the validity, completeness, and accuracy of financial transactions have been achieved. And they are designed to be application specific, as I've already mentioned. Now, when you compare application controls to general controls, the general controls are not application specific, but they apply to all systems. Take note that for general controls, we can also have other terminologies like general computer controls or information technology controls, etc. but they include controls over IT government or IT governance, right? IT infrastructure, security, and access to operating systems and so on. Okay, so application controls are more specific to some applications in the accounting information system. All right, so let's look at, before that, for example, let's look at operation system security. Operation system security. Now, the operation system performs three main tasks. Transactions are translated. High-level language transactions are translated. When we say high-level language transaction, we have something like COBOL, BASIC, C++, and so on. Okay. So this one, we can have controls in each of them. Okay. So let's go to the processing controls. The processing controls, we have what we call run-to-run totals, reconciliation, batch totals. But we can group them into three. Just we have the run-to-run totals. We have what we call audit trial, and then we have the batch totals. Honestly, we need to check these. For example, hash totals, they are about non-financial information. Hash totals are about non-financial information. So the non-financial information is also in the batch totals. Okay, so it's just about checking that these are accurately and correctly processed. So if, for example, batch totals, we have batch date, we have batch number, and so on. So you need just to check that this batch of transactions have been accurately processed. You need to be checking sequentially. Reconcile is also in the batch, right? That is basically the aim of the batch, to reconcile the input with the output to see that they have been actually processed, and especially to avoid the double processing of a transaction. Then for output controls, protect access to output, segregation of duties, as well as the format and content. So when we have access privilege, we have ability to generate reports, page numbering of reports, and end of report footers. So when we are using an ERP, which normally is based on integration, then this must highly be applicable. But another concern is physical control. Example, confidential information should not be printed on a printer accessible by all staff. Yes. So if you have information that is highly confidential, then that will be one of the challenges about output controls. Again, database queries, detecting irregularities or anomalies. Account staff, for example, they keep cash paid by accounts receivable customers. Okay, so this one is also relating to output controls as well. Okay, so that brings us to that. Let's go to the recovery. I think in our last lecture, I spoke about recovery. So the organization must have plans towards disasters that are not controllable. For example, terrorism. We know what happened in the US, in the World Trade Center on September 11, 2000. Is it 2000 or 2001? I've forgotten the date. Natural disasters, fire, flood, earthquake, and so on, which you don't have control. Online operations, web servers going down, and so on. All these can affect the accounting information system. and we need to have control measures for them. So when we say disaster recovery plan, then it's all about considering how to deal with such stress. So we have preventive and then you have corrective. If you are adopting a preventive control, then you want to minimize or prevent the occurrence of such disasters. And disaster recovery plan actually is a strategy that will be put into action. What strategy will be put into action in the event of a disaster that disrupts normal operations? For example, when the September 11 attack occurred in the World Trade Center, all the information systems were destroyed. So to resume operations as soon as possible and recover data that relate to its processes. So you must have control measures in relation to disaster recovery plans. And then you must make provisions for temporary sites. What are the key provisions? If a place of operation is destroyed, resume operation in a new location as soon as possible. We have what we call hot sites and cold sites. Hot site is a standby site which is ready if with all necessary equipment and data to be called into the immediate action. If anything happens, we can rely on the hot sites quickly. But as for the cold site, it is also available, but there are no equipment or resources that can be relied on and used. You see, for example, the medical squad, the not this we heard them reporting that they can actually admit patients that have been contracted with the COVID-19, but then they need some facilities, you see, so that can be compared to what we call cold site. So the site is available with basic services. They have all the human resources, but then the necessary equipment and data must be provided. But they don't have all the equipment that they will need to be treating patients who have contracted the virus. And staffing, you see, evacuation staff present at the location of the disaster. For example, during the September 11 attack, how were staff evacuated? You see, access staff after the disaster. Staff need to be familiar with evacuation procedures. Key employees in the recovery plan need to be contactable. You should be able to contact key employees. And then contact and staff responsibilities, rules and reporting plans, drills, promote, that is remote site staff, and so on. And then restoring business relationships. Okay, so a business is involved in networks or other organizations or individuals. So every business, you do not exist in isolation. You are involved in other networks. You relate to other businesses. So we have what we call the intranet, and then we have the extranet. The internet and the extranet links the organization to customers and suppliers. That's the extranet. So arrangements or deals with external organizations is executed by the extranet. Now, need to consult with such patterns and related bodies when developing a disaster recovery plan, right? So mock execution to the plan actually works. Okay, so in this lecture, we have gone through some control applications or some control strategies that must be instituted in the AIS, especially the control measures that must be observed in the data processing stages. Okay, and then we have also looked at the two types of controls for IT, the general controls and the application controls. Okay, so we'll end here today.